Hi guys, this is chemistry at your fingertips again back with the last minute revision on metallurgy. Generally, the name of the topic is general principles and processes in isolation of elements. Okay, and so let's see what exactly are we going to do in this particular topic. Okay, metallurgical principles. Since this topic actually deals with principles, so the concentration, and then you have extraction, and then you have the refining, right? These are the three things that you should emphasize more upon because the entire scope of the chapter is about discussing the methods, right? And then the different types of extractions or the metallurgical principles you have, right? And the most important and the most feared thing, that's the Ellingham diagram. So if you're not able to predict everything, at least try to understand the Ellingham diagram and try to understand the salient features of the Ellingham diagram. Okay, so let's see what are the things that you're supposed to study. Okay, first one, important ores of metals. Okay, try to understand each and everything. They might ask you as an objective question, or it is possible that they might just give you in MCQ. Okay, now smelting, carbon reduction, and then Ellingham diagram, basics and the salient features. Now I've chosen these three because these three are the things that students don't pay much attention about it. They think that yes, it could be done, but yes, I know you are able to understand all these things very clearly, but I want you to thoroughly do these three things. Okay, then the next part is concentration methods. Okay, concentration methods for flotation. Now, most of the times you'll see that MCQ has appeared like sulfide ores can be concentrated by which technique for flotation. Okay, then you have leaching. This is in the metallurgy of aluminium. Okay, Bayer's process, Hall's process, Serpek process, and so on. Try to understand this. They are pretty much simple. Okay, then you have the reduction, roasting, calcination. Okay, actually I would write here as reduction and you could say extraction, right? So these are the extraction methods. And then pyrometallurgy, electrometallurgy, smelting, bessemerization, these come under the reduction. Okay, so you have roasting, calcination, what happens, what are the properties, which if it's already an oxide you don't need to roast, right? Correct. Then directly you can go for carbon reduction or anything. Now bessemerization, try to do it separately. It's done in Bessemer converter. What is the charge that is charged inside the Bessemer converter, etc. Pyrometallurgy, high temperature blast furnace reaction. Electrometallurgy, what do you use? What is the electrolyte? What are the methods? What happens at cathode, anode, and the smelting process? Try to understand them. Try to do it thoroughly. Okay, and then you have the refining. There are multiple refining principles, but zone refining, very easy, very important for ultra pure metals. And then you have polling. Then you have electrolytic refining, Van Arkel methods. Okay, that is zirconium and titanium, right? So try to understand the reactions are pretty much simple. Plus, please do not miss these particular topics, right? And then you have learned the following one: reactions occurring at the blast furnace, not just the general reaction but reaction that happens in each and every zone of combustion, zone of reduction, zone of slag formation. What is blister copper, how it is obtained, and what are the constituents. Hall Herold process and Serpek process, try to do it. Okay, now, here are the different things that you would need. First slide is all about the ores of different elements: aluminium, iron, copper, zinc. Okay, and then you could just mark what are the things which are important, which is the actual ore. These are minerals as well, right? Then you have purification of bauxite and Bayer's method, Hall's process, Serpek process. So try to see the keyword. You have soda, bicarbonate, and here it's something different. Okay, then you have iron, so you have the different zones at their corresponding temperature, which I have already discussed. Okay, so just these are just handy notes, you could go through it. So this is the first zone, then you have the second zone, slag formation takes place here. Okay, these are just concise notes, correct? And the next part is copper. In copper, it's the only the only process wherein self-oxidation reduction happens, that's in copper. So this could appear like an MCQ. I mean, this may appear, I would say. Okay, so at least it's better to know about all these things. Okay, then you have extraction of zinc from zinc blend roasted in presence of air at 1200 temperature, and then reduction is done using coke. Okay, pretty much simple. I think that's it. The short revision session is now over. I hope all the chapters in physical chemistry, that is section 1, has already been done. Now, regarding the P block elements, I'm not going to give you any last minute revision techniques, but it's always better to do the oxides, oxy acids, the structure, anomalous behavior, right? And as much as possible. But if you are not doing much from the P block elements, at least make sure that the other topics which are doing, they're pretty much, what do you say, stronger. Okay. So I wish everyone good luck and thank you.